Learning medicine is hard work. Osmosis makes it easy. It takes your lectures and notes to create a personalized study plan with exclusive videos, practice questions, and flashcards, and so much more. Try it free today.
In statistics, it's often helpful to know the central point of a set of data, because it gives a pretty good idea about the whole data set. It's like a one-number summary of the data. For example, what's the number of words on a page in a book? Well, it's about 250. Of course, it depends on the book, but that's the one-number summary. The mean, median, and mode are the most commonly used ways to measure the central point. Let's start with the mean, which is also called the average. You can calculate the mean by adding up each value in a dataset and then dividing by the total number of data points. Let's look at an example. Let's say 7 students take a test on biostatistics, and out of 100 possible points, one student got 17, another got 19, 2 got 20, 2 more got 61, and the last student got a 62. The mean score would be the total number of points that they all got added up together divided by the number of students, which is 7. So that's 17 plus 19 plus 20 plus 20 plus 61 plus 61 plus 62, divided by 7, which is 260 divided by 7, which equals 37.14. To show this as a formula, we can say that the mean, written out as an x with a bar over it, is the total sum of the individual data points x1, x2, etc., divided by n, which is the number of data points. A mean test score of 37.14 quickly tells us that overall, these students didn't do well on this test. But the problem with the mean is that it can be influenced by an extreme value called an outlier. Let's say that another student comes along and gets a perfect 100 out of 100 on the test. That means that the average is now 17 plus 19 plus 20 plus 20 plus 61 plus 61 plus 62 plus 100, which equals 360 divided by 8, which is 45. This number summary isn't a very good summary actually, because 7 out of 8 students scored below 62, and the only reason that it's so high is due to this one high-scoring student. In this case, 100 is an outlier, and any data set with an outlier is called skewed data. To calculate the central point when there may be outliers, you can use the median. The median is the value which divides a set of data into two halves so that half of the values are greater than the median and half are less than the median. To find the median in our test scores example, you have to first arrange the test scores in order of magnitude like this: 17, 19, 20, 20, 61, 61, 62, 100. Then you have to find the midpoint. If there's an odd number of values, then there will be a middle number. But if there's an even number of values, like in this data set, there are two middlemost values, 20 and 61. So, to get the median, we take the average of these two values, 20 plus 61 divided by 2, which is 40.5, which is the median for this dataset. Notice that an extreme value like 100 doesn't affect the median, and that the median of 40.5 gives a pretty accurate one-number summary of the data. Like the median, the mode is another kind of statistical average, which does not get affected by any extreme value. The mode is the value that occurs most frequently in a set of data. And if there are 2 modes, it's bimodal, and with 3 modes, it's trimodal. So, using the same example of test scores, 17, 19, 20, 20, 61, 61, 62, 100, the most frequently occurring values are 20 and 61. So, this is a bimodal dataset with 2 mode values of 20 and 61. Now, keep in mind that in some datasets, all of the values are unique, and that means that there's no mode at all. It's amodal. That's why the median is the most commonly used as the central point when reporting data. Alright, as a quick recap. The central point of a dataset is the one-number summary of that dataset. The mean, or average, can be influenced by extreme values, whereas the median and mode are not as affected by extreme values. Between the median and mode, the median is usually preferred because some datasets are amodal.
Thanks for watching. If you're interested in a deeper dive on this topic, take a look at osmosis.org, where we have flashcards, questions, and other awesome tools to help you learn medicine.